Hello and welcome to today's webinar presented by Dlubal Software. Today we'll be working in our structural analysis and design software. The topic for today's presentation is reading results in RFEM 6 and RSTAB 9 with the new Dlubal API. My name is Amy Heilig. I'll be your moderator answering any questions throughout today's presentation. I'm the CEO of the US office and I'm located in Philadelphia, Pennsylvania. I'm joined by my colleague Andreas Horold, who will be your moderator. He's responsible for marketing and public relations and is located in our German office. And finally, I'm joined by Florian Hideman. He's going to be our speaker today. He's a project manager, also located in our German office. We always want to encourage everyone to ask questions throughout this GoToWebinar. You can do so within the dialog box shown here. If by chance we don't get to all your questions, we'll certainly send you a follow-up email afterwards. And with that said, I want to go ahead and turn it over to my colleague Florian for the rest of today's presentation.
Thank you, Amy, and welcome to today's webinar regarding our new features for the Dlubal API and with a special topic, reading the results via API and working with them afterwards. So what I would like to show you today, in general, the first part of this webinar is demonstrating our general updates and what we have as new features in Dlubal API. And this is quite a lot. I'm very happy that we can provide you some real progress here. We will showcase some features and a little explanation from my side, what is new and where to access it. And the second part is our main topics, working with the results mentioned. And therefore, I will show you some code. We go through the application together, look a little bit into debug mode and see what is, how this is structured in the background, how you can work with it, and some best practice tips. Also working with metric and imperial units with our results there. So stay tuned and I hope you enjoy today's webinar. First of all, we changed our pricing model. This is something to mention because maybe you tried it out in the last months and wondered if there is any change. And what we had in mind with this is to offer you also a free plan. And as you can see here on the left side, everyone with a full license of the program or student license can now access and test the API for free. So just try it out, go into the basic settings of your program. I will just make a quick look around after this, how to get access via the API, but there's also a first webinar in this series where there's more focus on the basic settings. So here today, I assume that you already know how to set it up, how to do your authentication, how to get an API key. All this is still valid, but we changed the subscriptions and the abonnements. So you have just to take care that you have an API key, make it in your extranet account. Look the previous webinar for that, please. But in change to that, we have another pricing model where you now can use 1,000 API requests per month for free. And you have full access to the features regarding input data and the results which we are demonstrating today. What's important to know or important to mention, we changed the way the requests are counted. In the past, there was some special requests we count. Now we are counting everything except for some service requests. Service requests are like printing the application info or get some technical informations of it, but everything that has to do with the modeling or getting results, it's a counted request, and you can check which request is counted in your extranet account and go to API and Cloud, and there you can see your requests which are charged and which you perform, and how many you are using, just to control yourself and see, okay, what's happening here if you need to test it and you are not sure what is counted and what not. If you want further information, just have a look on our website, please. There is under Solutions a part on the website where you can see these plans, and we have a updated FAQ section with the comment questions around it. And if you have special questions, etc., feel free to contact us via support emails or sales team, or of course, Amy is happy to help here. And we delivered, like promised, now also for RSTAB 9 and R section 1. The API is now available for these two main programs as well. And I will first show you as an example how to work with the different programs. What's really important and comfortable for you to know is the installation process and etc. Everything around this, the package you need. This is the same. The big advantage here is that we unified our API solutions into one single package. So from the client side, you just have to install one package, the Dlubal API, and within that you can use then RFEM 6, RSTAB 9, and by yesterday's new development, also R section 1. For today's webinar, we will focus the examples with RFEM 6, but they will also work in the same way for RSTAB 9. So with different programs, different instances getting in place, I would highlight a little feature, and some users we recognized stumbled around this. So if you have a look on the first webinar, we mentioned it's important that you set up your port in the right way, your gRPC server port. You can go in the main program options and settings, and here under this little symbol, you can access to configure your desired server port. By default, it's 9000. This is also the standard you use in your code. But when you have several instances open, we have a feature which might confuse you in the first place. So if the program by default has the same initial port defined, our software instances check if other programs are open and will dynamically give a higher number. So for example, if you have RSTAB 9 open and RFEM 6 on the same machine, and both are configured in a way that you want to use port 9000, obviously that wouldn't work. And so we just count it up to 9001. And this is the second field here, which is read-only, where you can see what is actually used. So the server port as used, marked here, is the one that you need to connect to via your software code. What else do we have new? Highly requested from some customers is the C# client, and we are very happy to announce that this one is available as well. So as you might already seen it, if someone of you is working with it, in our documentation, our API reference is really up to date. We also provide now C# code examples for each command and method and object. And we are happy that we can ensure mostly, I would say 99% of the features and functionality as well with the C# client, even if Python for us has a higher priority, and we won't promise that every feature, every access, every maybe special solution in the future is available for both. But we have built a pipeline where we can ensure that the basics and everything you can see here in the API reference is available for the Python client as well as for the C# client. So this is some good news on that. Today's focus in the presentation will also be the Python client. Then the last webinar ended with the statement that we need as a further update to make the base settings editable to work with the add-ons. And happily, I can say we also brought this to the table. So you can now edit the model base data via the API, read the preferences out. And of course, this is very important if you work with different standards, codes, or add-on settings, but also the member representatives setting options, model parameters, etc. are fully accessible now. There is a little code example. I will demonstrate this later on. And now, then getting to the main point itself, how to work with the results via API. We will go to 5 parts to have a look on this in detail. If you never worked with our results, it is worth to mention how they are structured, what is the technology behind. And here in Python client, we work with pandas data frames in the background. For those who doesn't know or who don't know what a pandas is, it is a very, very mighty data handling package for Python with a lot of built-in methods, a lot of handy features if it comes to big data for data science, and of course working with engineering applications. It is a very powerful, it provides very powerful classes like data frames and data series, where you can analyze it, work with it later on, export to CSV, export to Excel files, print them, read for specific values, filter it, etc., etc. There are a lot of options, and it is really worth to have a look into the pandas documentation if you are not familiar working with them. It's also very comprehensive. It is very, very well documented. The user guides, the examples here for the data frame, etc. There is a lot of stuff you can make use of if you are working with your results afterwards. And I will just give you a slight insight here, as well in another very popular library for working with units. But this is something for later. So we will just have a look working with the data frames, how to access it via our API, then change the base data settings as a new feature, and of course, how to work with filters, because filtering your results can be done via client side or directly on the server side. And it's worth to mention what impact does it have on, for example, performance or how to do it anyway. Big topic for you maybe, if you are on the imperial unit side of the world, let's say, our API in the per default offers the results, and this is also valid for the input values in SI units, so in metric units like Newton, meter, etc. And I would like to demonstrate you some kind of a best practice how to deal with these different unit conversions. And there is a very, very nice package. It's called Pint. You can see it's Pint is a very handy measuring unit for beer. And this guy here felt the need to program something to work with different units, convert them from meter to imperial, or even if you need to calculate from inch to foot, whatever. It has some very nice built-in features. And it is also very, very useful to work together with data frames from pandas. So it goes hand in hand, working with units and pandas data frames. So this is something I would like to give you on the hand if you not already know it, and show how to work with it efficiently to get to the same results via your API, like you see in your graphical user interface, where the units are maybe imperial as a setting and not SI units, metric units, like we deliver via the API. So now let's jump in the code and the program, what I would like to show today. I have an example model brought here. This is, just a little, construction here with steel cross-section profiles and timber together, so I can demonstrate with you some results from the add-ons as well. And this model will just provide some results which we analyze and get via the API then. So it is already calculated. We have some results here in the graphical user interface. You can see there are defined some imperfections in a few directions. We have the wind load assistant here. The snow load is applied, and yeah, it produces just a lot of different combinations now. And we will focus on getting some results and working with them via the API now. So I'm using an IDE here, PyCharm. It is available for free. You can, of course, use whatever you want. But here I will go through these chapters together with you to demonstrate how is it working. First of all, before we get into the result itself, I like to highlight what are the difference now you need to assess for RFEM and RSTAB, because we are quite proud that this is available via one package. And as you might used to, you know already from Dlubal API import RFEM, to work with the application here, and then you define every object, every call, every method with this package here. And what do you have to change if you want to work with RSTAB now? It's not so much. I copied the example from our website with multiple models, and you can see the difference here. Now we just import RSTAB, not RFEM, from the Dlubal API, and work with this exactly the same way. So it's really, really unified. The only difference here is that in RFEM, maybe you know it, we have lines as a basic element to model, which do not exist in the RSTAB world. So in RSTAB, we define our members by nodes. And the difference here for these model examples are only that in RFEM, we define the member later on the lines. Yeah, we just build here first lines and then assign the members to lines. But the main principle is absolutely the same. And you can very easy just search and replace RFEM to RSTAB in your code. And it should, if the logic and the capabilities of the software are respected. Obviously in RSTAB you don't have surfaces and solids and no lines, for example, but the other parts are quite the same. And this is very good if you have several applications which might slightly change between your programs. So demonstrating it here, we just run the script, and our example model now created here a silo, which has also surfaces in it. And here a simple example of a steel hall. And in the same way, I also have RSTAB open. It's empty for now. I go to the RSTAB script, do the same, just execute it. And I will now switch here. And you can see now also RSTAB can be controlled via our API. So far, so good. I will switch back to RFEM and open our example model for the results. So now let's get to the results. You should import pandas for the use with results, because when we try to get the results via API, this object here you will receive via the API command get results. This is not the data frame from pandas in first place. This is something you have to, remind and use it in your code, and make sure that we assess the results via a data frame, and the results here are stored in results data. So here under results data, there the pandas data frame is stored. So if I get my results from the RFEM API, I use this method like it's also described in our documentation. For those who don't know it, we have a very comprehensive online documentation here. And if you have a look into it, the get results, it takes some arguments. It can get the result type and the filters. Filters I'll show you later. And what you get then is an object where you need to access the data itself. And by accessing here the data, it will respond at pandas data frame. But only if you use the data method or of the object here. So how does it look like? What we are doing now is we make a connection to RFEM, and as you see on the right side, I have some results here. And what I want to get in the first place, I have to define this every time if I want to have some results. I want to have the static analysis nodes, global deformations. In the same way we use our own enums for the whole RFEM interface here. You can access our enumerations in the same way that you go to the package and navigate through the same results type here, and then you can see what is available as a result. And this is already a lot. We are further developing it from time to time, from week to week, and everything you can see here is a result. So this will deliver an object in which you can access the data frame. I've done it here. The result itself is an object in a, let's say, a self-defined Dlubal object. And in this, under data, you have the data frame, the result df here in this example. And what I've done is I choose, I want to have the node global deformations and just print them out. So here you can see the result. Mostly I print the application info to see what is running here. And then here is a glance into the data frame. This consists of nearly 30,000 rows. So very big objects. And if you print data frames, it's a built-in feature. They give you a preview of this. You can also define that you will print the whole data frame via these pandas options here, and how many columns are printed out. For example, if I now print every row, you would see here on the console output how far it's reaching. This is a limitation. How far you can see. The default value is 10. You don't have to use these options. If you cancel them, it will choose the default values. But we can have also a look into it in the debugging mode to get a better understanding if you never saw a data frame before. So just to get a basic understanding what is sticking behind. So the result object, this is a Dlubal object which contains the data frame. And by accessing it via results df, I want to work with this later on, I have the data frame here. You can also directly do it like in this example, but here in the webinar, I just split it up into several steps that you can better understand what is happening here, and this is laying inside. The data frame itself looks like this. Yeah, you have here several columns with the loading, node number, etc. And the data frames you get via the results. They look very different than these ones you get by the get result table. This is an important difference. So we separate between get results and get result tables. The get result tables, they have the methodology that we want to access every result table you can also see in the graphical user interface. And these informations here are not the same you get if you use the get results command. Later on, I will show in the end of the webinar how it's look like if you get a result table. And these are the ones you can access also via the graphical user interface. What we recommend is if you are working only with API and you get every result in this results type, you can work with this in total. This is like the internal information RFEM has to process the information for the graphical user interface, etc. But if you are used to the exact output you have in the graphical user interface, or you were working with Excel sheets in the past or exports here, or you need some informations like total, min, and max, then you can use the table view. So we offer two separate principles to access a result. One is more the internal information with get results, and the other possibility is the get result table. Two different API methods we offer. I showcase them later. Okay, now we got our first results here with the nodes. You already saw it was 30,000 node values. And what are the advantages now? You can work with data frames, for example. I enhanced this code here. So what we can do with a data frame in a very easy way, for example, we can only show, for example, the results filtering by a specific loading and in combination filtering by a given displacement. Here, now I'm working in millimeters. Later on, I show you how to do this with foot or inch in a data frame. And what happens now is from the 30,000 lines we have, these are only these ones now here, because I filtered for every line with load combination CO23 in combination where the displacements are bigger than 10 millimeters. So you can see this is a very nice built-in feature. It's available in the pandas documentation, how to work with it. And after I filtered these results, you maybe see here's only the displacement in that direction. And this is something I filtered here as well to say, give me only the node number and the UZ value. So with these few lines, you see, we go from this data set here to this one. So this gives a first idea how to work and make use of the data frame as built-in feature. So what now about add-on results and a little more interesting results than maybe member internal forces or node deformations? It's quite useful that you can now also see base data settings via API. This is very, very straightforward. You just make an API request for get base data. And if we print it, you see there are some settings you can do. And you have the standards, you have the general settings, the combinations, locations, wizard defaults, and this corresponds to the settings you have available here via the GUI. And as you can see here, some of the add-ons are active. In this example, it's steel, timber, structure, torsional, warping, and you can find these ones here marked as true, together with some other settings. This is very, very useful if you like to set it up completely automated via the API and doing a model from scratch. So how to change these things? The recommended way is that you get first the base data and then manipulate this object according to your needs. So first, if you make a new model, I already have one open in the background. So here now I will change the base data. And first step is, like I said, you get this one, and then you change it via accessing these properties, let's say. And for example, if you want to make the steel joint add-on active, you just change it here on true. And in the next step, you set the base data with this manipulated object. But here I want to change even something more because, as you know, we provide a lot of different standards and codes. And this is always important that these one correspond with your needs. And here I start in the example with our European codes and German national annexes. And as you can see here, they are set it up in my for the needs in my local country here, Germany. But maybe you want to change it to some other standards. And for this reason, you can just change it in this way here. But I defined a little dictionary here. You don't have to, but I think it's very neat to do it in this way, where you can say, these are every time my standard configs I want to use. So for example, for the load wizard, you take ACE7. For the steel designs, you take AISC 360 in the actual, or in the one of the actual versions, and the timber design groups, etc. These are just defined with the enums we provide under RFEM base standards. And then I build a loop which takes these keys and values here and change my base data object I got here from this call. And if I process this now, it changes the configuration of RFEM in the background. So if I go back now, last time we looked into it, we saw some European and German codes, and now it changed to ACE7, even with the wood standard group here, I've done it, timber design, and I also activated the steel joints add-on. So this is a very neat way to make your setup also automatical. You even can change, if you like, for example, things like the global axis, the orientation, that it's going upwards or downwards. Everyone has its own favorite settings here. So in this way, you can edit the base settings now and make add-ons active, change the code, etc. So once you were doing this, I go back to the European codes for now because I calculated the results with them before this webinar. And what we are doing with the results now is we want to see the results from steel design add-on and timber add-on, because this is also a new feature that we can access now a lot of different results. And our philosophy in the Dlubal API, for those who are maybe confused now, we go for a lean approach where you have only a few necessary commands and a lot of different objects you can define. So for the client itself, you see here, these are the available commands. They are as general as possible. And with the model or the object definition, we try to define everything you want to access or change in the program. So if you, for example, want to have a specific result, you define a result type and go into this with a enum value and hand this object over the result type to our getResult request. This is the idea behind. So the model, it just loads up in the background. Perfect. And I pre-calculated it with some results from the steel design. So here are some errors and warnings, but we have also gathered results and can see here we've done some checks about it, and I want to access these now. So what do I do? In the app with the client, I will get now in this call different results types. And because of the fact that at the moment we need to call different requests for different result types, in the future we are planning to also allow a list for this, so that you can define a list with different result types. But it has also some disadvantages. Here the advantage is that the big amount of data you transfer, it is more stable to do it in small chunks. So if I want to have my results for steel design, I have this result type here with steel design, member design ratios. And for timber, I have a different one. And I built now here in my construction a dictionary where I put every request into this dictionary under the key steel and timber. This is my personal solution here now to have a single result dictionary in the end, which contains the data frames under this key here. And this has the advantage that we have it with chunks. And if we have a big list maybe in the future with a lot of data, it could be 100 or 200 megabytes or even a lot more. It's from a stability point of view, maybe risky to do it in one request, but we are working on this and trying it out. How does it feel? For now, we are doing the same. We make single results, and I put them here into a dictionary. And then I wrote a function to analyze this result, these data frames in the result dict. And I want to have every member number where the design ratio is above 1.0. So the function here, it's just takes a data frame. I give it a label that we can use in the print. And again, I make use of some pandas features because I want to filter every line where the design ratio is bigger than 1 and have the member number. It's a similar way like with the nodes, but now with design ratios here. So what is happening? The API is now getting, with 2 results requests, 2 different data frames, packing them into a dict, and then analyze and filter it in the background. So, and what we can see here is it found that for steel design, no member is with a design ratio bigger than 1. And for timber design, there are 1, 2, 3, 4, 5, 6. And I just ordered them in a sorted list here for me. If you do something in your code, you have your own use cases. This is just for demonstration purposes, just to show how this works and what you can do with it. And as you can see here, there are a few objects in timber design where this model here is not optimal from a statistical point of view. But for demonstration purpose here, we found that some objects here have design ratios over 1. And if we go into the details, here you will find the same objects like we found via API. For example, member 331 was overloaded, and this is also one in the list. And if we go to everyone else, we analyze these data here via the API now. So as you can see, we can make use of the add-ons as well. And what is available, you can see it on our online documentation or here directly in the API. This is a lot by now. We have it for aluminum design, concrete design, pushover, spectral stability. It should be almost complete. If you found any result you need, which is not part of this list yet, please contact us, write us an email, go to the support contact, and we will try to make it possible for you. We want to have a full approach that we have a complete access to all our relevant results here. So, and as you see, it took some time to transfer all this data, and the analysis of it is very fast with Python here, my local machine, but the transfer took some time. So it might be useful to filter these things. So there are two strategies you can use. One is on the client side, like we did it in these examples here. So we just get all our results and then work with them by filtering in the data frame. Again, I want to have in this example the member internal forces from the static analysis. And what I've done now, I wrote a little function for me, a little helper function which stops the time. So when I use this time block here, it's a self-written function that will measure the time needed for everything what happens here in this block, just to compare it later. I fetch some results from RFEM, the member internal forces. We print this data frame first, and after that we will filter it that we only have the results for the load combination 1 into it. And then we print the filters data frame. Furthermore, in the end, for later use, I save this data frame to a CSV file. This is also very, very easy when you're working with pandas data frames. So let's see what happens. It should need around 10 seconds to get the results via API. And this is, as you will see in a few seconds, because of the reason that we have over 500,000 rows of data into it here with a lot of different columns. So this request took 9.8 seconds on my local machine here. And as you can see, we have 583,000 rows with 15 columns. So this is a lot of data. And when I want to work with load combination 1, for example, in my code, or another one, it would be fine to just access around 2,000 rows at one time. It really depends what you would like to do with your results. It can be nice to get everything once, save it into a CSV file or pickle them with Python and work with them later in the code without using our API anymore. Or if you want to see some specific results and working with them and do some iterations, maybe it can also be nice to filter them by server. And this is the alternative here I would like to show you. We want to have the same results in the end, everything for load combination 1. And for this reason, we can use the optional argument result filter in our getResults method. So here in first place, I just had the argument result type. And now I give also a filter. The result filter is again an own API object we defined, and it works in this way that you need to give a list. Yeah, so that you can define more than one filter in this list. In this example, only one item is in the list, but yeah, just to have this in mind, you can stumble around this if you are not used to. And we want to have the filter that we only want to have the loading column, and the filter expression is combination 1. Yeah, it's the same information like here, but we are giving it now in the API command. And again, I will now stop the time. How long does it take? And you see it's a lot faster. In this case, it takes only 0.07 seconds. So this now 0.04 seconds. So it's 200 times faster now to get these 2000 rows here with the right combination. And if speed and performance is an important factor and you want to lower the amount of data you transferred, you can also use these server-side filters. So have in mind that this is a valid option, and technically it's quite the same. Now the server is filtering the data frame which it transfers to you, and you don't have to do it after you had the results delivered. So, and maybe you already wondered, if you are used to imperial units, what these strange numbers here are. I want to demonstrate you now a little bit of best practice, how to deal with the different units here. And therefore, as mentioned before, I'd like to give you a short introduction into the Pint package. This is nothing we provide, it's just a personal recommendation to use it in combination with the pandas data frames. From the previous examples here, I stored the results in CSV files. Yeah, so we will work now in the unit conversion examples with the results I saved to CSV. And yeah, we have the results data frame here, which is the complete result type for members internal forces. Yeah, the over 500,000 rows. And we have also the filtered versions here via the client and via the server. In fact, these are the same, but I stored them here in separate data. So if you have the result data frame CSV, can open it. This data view, you see it's 580,000 rows with 16 columns. And the values you have here are just floats. There is no special unit type, no special data type. These numbers here are just numbers, and you have to know that we deliver via API in metric SI units. So it would be maybe handy to transfer them in units if you work with them. And for that, we can make use of the Pint library. How does it work? I made a short example here, and it's very easy to use. You have, first you build a unit registry. This is also explained in their user guide. And now I define length, for example, in kilometer. Just say I have my value here and multiply it with the kilometer from the unit registry. And once I've done that, is the length in kilometer is now very clever, because if I print it, we see, okay, it gives a string with 1 kilometer. And I can now say, give me the length in kilometer and transfer this to miles. And now it calculates automatically into a mile and print me that. And if I want to have only the value, it's also easily possible. I can access the value via the magnitude method or property of this new type. The length in kilometer now is a data type pint. It's from this package here, and it provides all these different methods like conversion. And even if you don't want to convert to total different systems like metric to imperial, it's very nice to work within in the same unit space. So just to make it crazy, I have a length in centimeter, a length in inch, and a length in foot. And I want to have the sum of these lengths. Usually it would make, at least for me, who's not used with imperial units, make a big headache. But here I can now just sum them up, and pint is handling the rest here. And now I add centimeter, inch, and foot, and I want to print it in yard, just because. And you can see it's working really, really fine. And yeah, I've tested it, so it should be the right value. So, but we have data frames and want to handle it in a bigger style. How could we achieve this? I built a small introduction example here. So what we are doing now is I just have a loader that provides me my results data frame again from this saved version here. And we print out the original results to remind us what we have here. Yeah, and I will do this several times over this example. So first we just import the result data frame like we are getting it from the API, and we show the types. And then we make an analysis, which is the maximum normal force and the minimum normal force in the whole result data frame. Then in the first step, I make use of the pinned pandas package. Yeah, it's from the same author like pinned, and he provided an adapter. Don't ask me into the technical detail. I'm just aware how to use it. And via the documentation, you see if you have your pint unit registry, you can use it to connect with pinned pandas in this way. And after that, you are ready to go to work with data frames as well. So I made here by myself, like I think it was a clever approach, a unit mem for my sources. So I know our API provides these columns here with this units, Newton and meter, and Newton meter for the moments. And I go now in each column of my data frame with this string here, and define this new as type with pinned. So this works now because I have used the pinned pandas package. It's a little bit magical, but once you get used to it, it feels very natural and direct. So I just redefine my data frame in a way that every column with this index here is now from the type pinned and with the given unit. And then we will print this data frame, which we changed, and see what types we have now and what happens if I print them. And then in the third step here, I defined my target units, like a kilopound and foot. Maybe you are used to this a little bit more from the imperial side. And what we just have to do there is convert them with a pinned to target unit. So last step then, print out the converted units and see what changed and how the results are looking. So you see it goes very fast because I used here the filtered results from the server. So the original results, as you saw it a lot of times now in this demo, just floats, just values. And a maximum of 33,000 you need to know that these are newtons later on. In the second step, where we defined with the source unit maps, it changed a little bit because now this data frame with the pinned units, it contains the pinned newton, the pinned pint, meter, Newton unit types. And in addition to that, pint says, okay, this is a float 64 type. You can work with NumPy packages as well to calculate with these values in the same precision like before. For this example, I only transferred these ones and not the others in the data frame. And if you print now min-max values, you have the values here in Newton, but it stays the same. And now in the final result, I just converted them to the target unit, kilopound and kilopound per foot. And you can see it just converted them, and my min-max values changed now. And when I go to RFEM now, we have filtered results. I filtered them for the load combination 1. Let's see if we get the same results here. Static analysis, results by member, combination 1. And you can see here in the left corner, max n is 7.547, and minimum minus 8.254. So now we have the same results like you are used to when you're working with imperial units in the GUI. But of course, this version here, this format is not very good for practical use. So in the examples, I just wrote you to give an idea how to work with this as a best practice style, a little module, the unit converter. And here I have just defined a unit mapping where I want to define once, okay, every time I have a column with n, I want to transfer this from or convert from Newton to kilopound. And even if it's made with vertical shear forces in y direction, or if it's defined in local axis direction with u and v, I just define here from what unit I want to convert. And so this little function here, convert metric to imperial, this is not part of the API, but you can write a little util function like I have done here and use it. It's very, very small code for a big advantage, I would say. So if I use this, I put into a data frame, the mapping table, if it's not defined, it will take this from the module itself. And then I just iterate and define it first as type of the source unit, and then convert it to the target unit. And this is the same result here you saw in the previous example with this helper function. And now I'm doing this with the result data frame, which contains over 500,000 lines, so over the 500,000 member forces. And we stop the time, how long this conversion will take, just to take a little bit maybe of the fear that this won't be practical usable. So I have now the data frame, which we get from the API, use my function to convert us with the pint and pint pandas adaptation, and then reprint them out and see for max and min results in imperial units. And as you can see, it took under a second, 0.97 seconds. And here now, everything is now in imperial units. And since we cycled over every member force, I can maybe go to DS1 because it should have the heaviest one. So maximum is 45,729, and minimum 45. This value, and you can see this is working right. So this is quite a clever way to make use of our data frames, make use of some popular Python libraries. And I would like to give you this in the hand. Of course, after the webinar, I upload these examples here on our website so that you can study this for own purpose. So last topic, before we close now is result versus result tables. I want to show you in the last minutes how this is working. It is in fact now in the same way you are used to. We just have another API method in comparison to the get results. We also have get result table. And if you want to have a get result table, you have to filter. Yeah, this is something different than working with our normal get results function. Here you can define the result type and you get everything. The filtering here is optional. Yeah, if you do it on the server side, you can make use of a result filter, which looks like this, but you don't have to. The result table are working differently. If you want to get a result table, you use a different API call. And this needs the filtering because in RFEM, in the GUI, you would have the same options here. You would say it's a result by member, and you filter these tables by, for example, a load combination. And you go to a specific tab here. And you have to put these informations to get the same result table also in the definition here. So you define the table you want to see. This example is a static analysis member internal forces. And you have to define the object you want to see. In this example, it's an RFEM object from type load combination. Yeah, the enums are available in our package with the number 1. So again, we will expect the result table internal forces with this setting. So we want to have exactly this table now via API. And you can see, I just print every column here. You get exactly the same layout like you are used in RFEM, but be careful, you have to check it. Some examples here have different columns, like if you have the normal force here and the vertical shear forces, these are with the index for the global axis. Obviously, if you have the internal forces here, it can also be that you have the local coordinate system. So here in the result table, the indices are for the local coordinate system. In the RFEM GUI, it's for these are the global indices here. So different ones. Make sure that you double check what you have here delivered in the result tables. And again, same principle. If you make a result table call, you have to access the data within to get the data frame. And what I did here is just make use again of my converter to get this data frame here with the member forces of combination 1 and convert them to imperial. So the values you can see here are converted. And you can see here, we also print out the summarizing lines, which are usually at the end of those tables. There's a total max min here. And now we have a total max min, again with 7.5. And without any processing or searching by myself, the result table is providing this as well. So the total max, total min, this is a tag column. And for n, these are the same values we have seen before. So the last thing to close with, get errors and warnings. Also nice and handy feature, because this is also a special type of a result table. And just to mention it on its own example, via accessing the result tables, if I have an error and a warning, I can access this table too. And this is something clever if you want to go to error handling. If your calculation went wrong or it aborts or anything, you are usually interested in why this happens. And if you have an automated workflow, maybe you need to process this information to give feedback to the user, do another iteration run, change some settings, etc. In this calculation here, this is empty, the data frame, because everything went fine. If I change the model slightly, and with slightly I mean delete one of the main columns, I just try to calculate now, let's say self-weight. You can expect that the calculation will not happy about this, and we have some stability errors. So when this happens, of course, I expect you to do plausibility checks and you have a try except loop if you want to calculate with our API. But maybe you want to access now this information, and this is also a result table. We have the errors and warnings here. And you are used as a user to look now where it happens, what can I do? You have an error warning code, where it happens. And exactly this information is accessible via the errors and warnings table. So this data frame here is printed in the short version. So we set the option that it prints every column. Oh, yeah. So from import founders. So you can see the full information is available. You have the columns here, like in the GUI, which load case, which object, the warning number, and what is the text. And if you would access the data frame directly, you can see there is a full description available. We can go into the debug mode to show it. Click in the data frame and you see here, this is accessible as data completely. The same strings. So, and last thing has also to do with error handling and how to manage if there are results or not. If your calculation went happy or not, and you maybe have some if loops, if the plausibility check was successful, if the calculation was successful, etc. Maybe you want to check in combination with the get errors and warnings if you have any results. And what now is the case? I don't have any results because I deleted them and everything failed. So I can ask RFEM, do you have any results? And I want to see the value of that. So here's a pair. We are getting back where the value is true or false. And I can also check for a specific load combination if we have a result. And then you can build in your own loop. Okay, you only make an API request if this one is true or false. Yeah, this is the idea behind that you can control your workflow a little bit deeper. Oh, I didn't close the other call, I think. Yeah. So here now I get the result. I have no results. And of course, I also have no results for load combination 1. Yeah, if you give no arguments, it just checks, do you have any results? If you give a specific loading, it checks for this object here. And my relevant loading here is defined in the way with an RFEM object ID from object type load combination. You can also use load cases and different numbers here corresponding to your RFEM model. Let's see if I just give the column here back. And I test it. I calculate only load combination 1. Now I should have some results again. but only for this load combination, not for another one. And let's check it here. So what should happen? We should see that we have results in general, and we have results for load combination 1. We don't have results for load combination 2. And here I just got again result table member forces for combination 1, which I could have controlled by the true value I get from this check here. So that was a lot of code in detail. I hope you enjoyed it a little bit. It's difficult to show this very theoretical stuff and codes, but I'd like to also to give you a deep dive how it works, how this looks in action, and yeah, you are only limited by your creativity what to do with it, with automated design checks, with user-defined workflows, process the informations in other workflows, whatever you want. But here you have some tools now where you to work with our API, and yeah, in the end, the results are the most important thing we would like to have, because yeah, if you have a successful calculated model, you want to do something with it, right? So with this demonstration here and this deep dive, I would like to give back to Amy, and thank you very much for your attention today. Goodbye.
Great. Thank you, Florian, for that helpful presentation today on the Dlubal API. So we'll go ahead and wrap up today by visiting our website, dlubal.com, where we have released our new Dlubal community. So you can find this button up here at the top of our website here. And this allows users to ask technical questions. You can engage in other discussions with other users, and you can also interact directly with our team, again, with any questions or comments about our software. So go ahead and give that a try again directly on our website up here at the top. If you are interested in scheduling an online demo with us, you liked what you saw today, or you're interested in discussing some of the other capabilities of our software, we would love to set up a short demo with our sales team. So you can go ahead and scan the QR code shown here. This is available in the GoToWebinar handout, or you can visit our website at dlubal.com, and we'll certainly be in touch to coordinate further. We will have many more upcoming webinars. You can register at dlubal.com under support and learning webinars. As most of you know as well, we tend to send out a reminder email before these webinars take place. PDH certificates will automatically be emailed to all participants who were here for the full presentation. So this is a requirement of the states that we are pre-approved providers, that you are here for the full 60-minute duration in order to receive that PDH. If you did watch with a colleague or in a conference type setting and you yourself did not register for this GoToWebinar, but you were here for the full duration, feel free to send us an email at info-us@dlubal.com. Let us know who you watched it with, and we will certainly send you a PDH to your email directly. Now, one more thing is that this is not instantaneous directly after the webinar ends. We do usually need about a day to send those emails out. So just keep an eye out for that. And with that said, we want to thank everyone for attending. And as always, we hope to see you at the next presentation. Thank you.